We'll proceed in calculus theorem. Calculus theorem. We are proceeding discussion in Newton's theorem. Newton's theorem, I believe, actually I was trying in search called Newton algebraic equation and this and that. This is famous Newton theorem. That is how to estimate a solution of an algebraic equation, and that is fx equal to 0. Function over x equal to 0. That we call it gx equal to 0. If I have a function gx equal to 0, then what will be x in gx? There it will be 0. Gx equal to 0. Okay, if that is the case, gx equal to 0, at what value gx is a function of x and it will be 0. Okay, if that is the case, then Newton suggests that take one algebraic equation, and that is x minus gx by differentiation of gx. X minus gx by differentiation of gx. What is gx? Gx is the algebraic equation that need to be solved, and gx should become 0 at solution x. Okay, what example we are always taking is consider x square equal to 2. If x square is equal to 2, if x square is equal to 2, then what is value of x? Sir Newton is saying, do one thing, make 2 left side. Now it becomes x square minus 2 equal to 0. Consider x square minus 2 is function of x. We call it g in bracket x bracket close. Gx equal to 0. Now what is the solution x for which gx will become 0? The answer is square root of 2. If I take x equal to square root of 2, then x square minus 2 will be 0. But square root of 2 is not the result. I should give the result in fraction. In that manner, if we see in the drawing manner, then this is the g gx equal to x square minus 2. If I just draw a graph of x square, if this is x-axis, then this is the graph for x square. If this is x-axis, then this is the graph for x square. If this is x-axis, this is the graph for x square. Now I want graph of x square minus 2. Then I have to bring this 2 down. 2 down. Whatever we are seeing, it will come exactly 2 down. Now this is x square minus 2 graph. This is x square minus 2 graph. When x is 0, it is minus 2. Makes sense? Earlier when x was 0, that is graph of x square. When x is 0, then gx is 0. Now when x is 0, gx is minus 2. And then it will cross x axis at this point. What I am trying to say, consider this is x axis and this is gx axis. X axis and gx axis. G in bracket x bracket close. X axis and gx axis. Now I have a graph called gx equal to x square minus 2. This is the graph that is called x square minus 2, where at x equal to 0 it is minus 2. And there is a point where x equal to square root of 2, it is crossing the x axis and then it is passing like this. Tell me a value of x at which gx is the 0. Gx means at any x, if I draw a vertical and it is vertical is going to hit the graph, that height is gx. Tell me the value of x at which gx will be 0. Draw the graph and see at what point this gx is crossing x-axis. At that point, vertical is 0, and that is the solution. This is what Sir Isaac Newton is saying, that is the solution. Rather than x square equal to 2, find the value of x at which the x square is 2. If I take this one, then I consider function over x, that is fx, f in bracket x bracket close. Function over x is fx, and fx is function over x, fx is x square. Fx equal to 2. Fx is equal to 2. Tell me what is x. Then this is fx, x square. And tell me a value of x. Tell me a value of x. If I draw a vertical, then this will the fx means height. So at x, if I draw a vertical, this height is fx and this is x. Tell me x for which this height is 2. Okay, someone has to find, that is the solution. If I draw gx, that is x square minus 2, then this is the graph. 2 come down. And then tell me value of x where gx will be 0. Anything. Okay, Sir Newton is saying do one thing. Take a formula that is x minus gx by differentiation of gx. X minus gx by differentiation of gx. Okay, now place any x, arbitrary x, because you don't know the solution. You don't know the solution at which at that x dx will be 0. Yes, I don't know the solution, that is true. Okay, if you don't know the solution, then place any x value in this equation, x minus gx by differentiation of gx, x minus gx by differentiation of gx. If gx is x square minus 2, then it will be x minus and then x square minus 2 by differentiation of gx is 2x. X square minus 2 by 2x, before that minus, before that x. Try any x, x may be 1, 2, 3.5, whatsoever, and see what the result it is bringing. That result will be near to the actual result, that is the square root of 2. Okay, so whatever input you are placing, see the output, and that output you feed again to the algebraic equation, see the output. That output you feed again to the algebraic equation, see the output. If difference between output and input is coming to lower than the prescribed one, lower than the error, we call it error output minus input, then that input is the answer as per Sir Newton. Now we are trying in multivariable case, and two proof we have already given. One proof is through tangential surface, and one proof is through the derivation of Jacobian. Okay, how Jacobian works means interchanging the coordinate system. That would be better word. The concept, the technology of interchanging the coordinate system. What is the multivariable function that we have? Earlier we have x square equal to 2. Now we have x square plus y square equal to 4. 4. This is one equation, and another is y equal to x. Y equal to x is a straight line 45 degree from x axis. That is a straight line. X square plus y square equal to 4 is a circle of radius 2. It is circle of radius 2. Okay, then at what will be the x and y point where this line would meet each other? I believe it is all right what I am saying. X square plus y square equal to 4. If this is the circle, if this is the circle where radius is 2, and this is the center, this is x-axis, this is y-axis. In that manner, this is a slant line that is passing. This is origin and this is y equal to x. Tell me this point and this point. This x comma y, this x comma y. Understandable? Where x and y are same, because line equation is y equal to x. So x and y must be same wherever they make the intersection. And another condition is x square plus y square should be equal to 2 square. That will be x will be a square root of 2 plus minus, because there are 2. So x will be plus square root of 2, y square root of 2, and here x will be minus a square root of 2 and y minus a square root of 2. That is the solution. Both are same and they are confirming that equation also, that is x square plus y square is equal to 4. Okay, how to solve this through Newton equation. So Newton theorem says that if it is a single variable, then x minus gx by derivative of gx will give the next value that will be near to the solution. Subtract input and output. If you take any input as x, consider in our equation x square equal to 2 or x square minus 2 is gx. If I take x as 2, consider I think that x will be 2. Then if I place 2 here, or if I think x may be 1.5, because I don't remember what is the square root of 2. I think, consider 2. I take x as 2, then 2 minus then x square, that is 4 minus 2, 2 by 2x, 4, that will be 1 by 2, 2 minus 1 by 2, answer will be 1.5. 1.5, that is the output of this algebraic equation, will be near to the solution. Input is 2, output is 1.5, error is zero point 0.5. Then feed 1.5 back to the equation. 1.5 minus x square, that is 2.25 minus 2, that is 0.25 by 2x, that is 3, that will be 1 by 12. 1.5 minus 1 by 12, that will be the answer. Okay, that will be 3 by 2 minus 1 by 12, that will be 16 minus 1 by 12, 7, 18 minus 1 by 12. Okay, that will be 17 by 12. How much it will be? 17 by 12, 1.5, 4, 1, 6, 1.416, 1.4166 will be the result. If I feed 2, I get 1.5. If I feed 1.5, I get 1.416. If I feed 1.416, it will be more near to the result. But I don't know the result. What I can do is see the error between output and input. If error is narrowing, after some time error will become lesser than 10 to the power minus 2, 10 to the power minus 3, 10 to the power minus 4. See the acceptable error. How much error below that it will be acceptable, and that is the answer. What about multivariate solution? One solution is the way we derive Jacobian matrix for the transformation of coordinate system. Okay, that is one solution. Another solution is Taylor series or the tangent surface. Tangent surface or Taylor series, more or less they are near to each other. Today we will talk about something else. Okay, what is something else? That is, first Jacobian calculation was difficult. Previous people have to watch, I believe, 2 days prior video, 2 days prior. So first Jacobian was difficult. Jacobian was typically, if I have any expression as fxy dx dy, integration of x minimum limit to higher limit, y minimum limit to higher limit. If I have this kind of scenario, then fxy dx dy, typically this is typically falls in volume calculation. Volume calculation. Or if I have dfxy by dx, cross product dfxy by dy, that we will see one example where we will talk this in vector terminology, because vector is coming up now, and that we are seeing very clearly. Vector science, matrix science, these science are entering into this arena. Vector science, we have made a series of video vector in calculus, but we have not made a vector matrix calculus. So now we are entering into vector matrix calculus. Okay. Second thing we talked about, that if I have a function, consider this is xy plane. Consider this is xy plane. Now I have two functions to solve. One is x square plus y square equal to 4. As per Sir Newton theorem, I have to bring everything on one side and make it equal to 0. Then x square plus y square minus 4 equal to 0. And I can call it g1 x comma y. G1 is the algebraic function. G bottom right 1. G1 in bracket x comma y, which is a function of x comma y. G2 x comma y, which is a function of x comma y. Understandable? G1 x comma y, G2 x comma y. Okay, if that is the case, then there are two functions now. G1 x comma y, G2 x comma y. G1 x comma y is x square plus y square minus 4, and G1 x comma y is equal to 0. Another is G2 x comma y, and that is y minus x, and G2 x comma y is 0. I have to find somehow x comma y, for which G1 x comma y is 0, G2 x comma y is 0. I have to find x comma y. Okay. Now if I try to proceed in the Newton's theorem, then solution is x. Now here it will be x comma y, or I can say Newton's solution is x I. X is a value and I is the direction of the vector. Or I can call a matrix where there is only one vector is there. Matrix is nothing but set of vectors. I can say my vector are in row manner. One vector, consider there is a vector called x1i plus y1j, and there is another vector called x2i plus y2j. If I place these two vectors in matrix in a row manner, then first row will be x1i plus y1j. Next row will be x2i plus y2j. This is called row span. In a row manner, the vectors are arranged in matrix. Matrix is nothing but set of matrix is nothing but set of vector. It can be input vector, it can be output vector, it can be attenuation vector. We will see more on this. Anyway, vectors can be arranged in column manner also. First column x1i x1i y1j, second column x2i y2j. This is called column span. So this is the signs of matrix. If I talk about Newton's theorem in vector and matrix, then solution, that is x minus and gx by dgx by dx, or derivative of gx, can be rewritten as a matrix where there is one row, one column, and that is x, that is x or xi is the vector. Okay, minus then gx. Gx is nothing but a matrix where one row, one column is there, called gx. Makes sense? Divided by a matrix where there is one row and one column, that is dgx by dx. All are I, all are in I direction. Okay, dgx by dx, gx, dx, or and then x. Understandable? If I leave the ij fundamental, then it will be a matrix x minus matrix gx by matrix dgx by dx. Now, if I talk solution in dual variable, then first x will be replaced by a column. I am considering a vector is arranged in column manner. If I have vector xi plus yj, it will be written as x, y in one column, two rows. In a matrix, two rows in one column, x, y. This is the matrix for the input. Minus, and then numerator is g1 x comma y, g2 x comma y in matrix and in column. Means I am considering g1 x comma y, g2 x comma y is a vector where I component is g1 and j component is g2. Very surprisingly, but this is how we are taking, because it is multivariable case. So it is one matrix x, y, bracket close, minus numerator is g1, g2, bracket close, that is the matrix sign, Means G1 is the x component and G2 is the y component. Divided by, and then we have dg1 dg1 by what? Dg2 by what? Earlier it was dgx by dx. So what I can do, I can rub off everything. X equivalent xy in matrix. I can just say x comma y because we don't know where they will go in column manner, they will go in row manner, or they will be something different. We can just symbolize that x comma y. X will be replaced with x comma y minus numerator. Earlier it was gx. I can write a g1 x comma y comma g1 bracket x comma y bracket close comma g2 bracket x comma y bracket close divided by, now I have to find equivalent of dgx by dx. Understandable? Now we will go back to the original concept, how our solution is x minus x minus gx by differentiation of gx. Many times we have demonstrated. I don't mind demonstrating it again. Okay, concept is that our gx in single dimension is x square minus 2. Example. Now gx is crossing x-axis at this point. This is point, I call it x0. X bottom right 0, x0. At x0, this line is crossing the x-axis. Makes sense? When x is 0, actually x is 0, height is minus 2. When x is x0, then gx is 0, and that is the solution. Consider I am drawing through my hand, and by mistake I drew like this, because I can make mistake. And I'm assuming this is the solution, but actual solution is this. Or I'm drawing like this and considering this is the solution, but actual solution is this. Okay, someone can go in mathematics manner. My solution is x0. That is same as x minus in bracket x minus x0. Same thing. This proves that whatever we are making assumption, consider x is the assumption we are making. The way we started with x equal to 2. So if I start with x equal to 2, x equal to 2, x minus in bracket x minus x0. X is the beginning assumption I made minus how much is the difference between x and x0. If I take this as x, my assumption, and this is x0, then how much this gap is, that gap I have to subtract from this point and I get the solution. Make sense? If I make this as a guess, x, where this is the solution, then x minus this difference, that is x minus x0, means x minus x0, or the delta. If I subtract, then I get the actual answer. How to calculate this delta? X I know. How to calculate this delta? Okay, consider that I am drawing like this. Up. I am drawing up. I'll try again. Okay, consider this is x. This is x0. This is x. Up. I'll try again. Yeah, this is what I am saying. Consider this is the actual graph where gx is crossing x-axis at x0. But by mistake, I am saying it is crossing x-axis at x. At this point, the error is this much, that is x minus x0. What about error in vertical? Here, error is 0 because vertical is 0. If vertical is 0, then error is 0. But here, at x, vertical is gx, and gx is the error. Gx should be 0. If gx is the error, and this point, let's calculate the differentiation dgx by dx. At this point, if I calculate dgx by dx means how much gx vertical is changing per unit change in x-axis at this moment. That is dgx by dx. Now I can rewrite it. Dgx by dx is the change in y when there is 1 unit change in x-axis. I want gx. I want gx change. Gx is this much and we want 0. If dgx by dx is the vertical, then horizontal is 1. If vertical I want gx, then how much will be the horizontal, that is from here to here? This one I am trying to find. Then it will be 1 into gx by dgx by dx, and that is this amount. Now I have to subtract from this. So x minus gx by dgx by dx is the solution. Okay, if that is the solution, then how solution will be in 3D case? Now 3D case, we have two graphs. One graph is G1 XY. This is XY plane. Consider this is XY plane. Consider this is X axis. This is Y axis. This is origin. Or this is X axis. This is Y axis. And this is origin. Now this is XY plane. I have a graph called G1 XY. I have a graph of G2 XY. G1 xy equal to 0, there will be a point called x comma y somewhere where given xy surface will come and hit the xy plane. Height will be 0, z will be 0. There will be x comma y point where g2 xy will touch the xy plane. Note down all the x comma y for which g1 x comma y will become 0, that is x square plus y square minus 4 will become 0. Note down all the points where it is possible. Now take another g2 x comma y, that is y minus x. Now see where they will become 0. Y minus will x surface, it will become 0 at all the point where y and x are equal. X square plus y square minus 4 will be 0 at all the point where x is plus minus a square root of 2 and y is plus minus a square root of 2. I believe there will be 4 points. We will try. X is a square root of 2 and y is minus a square root of 2. Then 2 plus 2, 4. 4 minus 4, 0. X is a square root of 2, y is a square root of 2, again 0. X is minus a square root of 2, y is a square root of 2, again 0. X is minus a square root of 2, y is minus a square root of 2, then again 0. Means g1 xy will be 0 at 4x comma y points. g2 xy will be 0 at many points where y and x are equal. In that manner, if I take intersection, then solution is coming as minus a square root of 2, minus a square root of 2, and a square root of 2, and a square root of 2. Only 2 points will validate, 2 points will go away. These proofs are not there in any of the book, anyone can try. Now we are trying to find that how G1 is changing over X, what I am trying to say. Consider this is the G1 graph. Okay, anyone can draw the G1, x square plus y square minus 4. Consider that this is the G1 graph. Consider this is the G1 graph. This is G1 graph. This is above the xy plane. If this is a G1 graph, and I take any point here, if I draw a vertical down that is going to hit xy plane at x comma y. At this point, I am trying to get this point. If I take the height, understandable. Take any point on xy plane, x comma y, draw a vertical, and that vertical is going to hit the surface here. At this point, g1 x comma y is the height. What is g1 x comma y? g1 x comma y is the height at point x comma y. How much g1 is changing if I go along x-axis, keeping y constant? This is called dg1 by dx. How this vertical will change if I move along x-axis? Means what I'm trying to say is at this is considered, this is origin, this is x-axis, this is y-axis. Now take any y fixed and draw a horizontal line. This will be variable x at any fixed y, and that variable x, draw a vertical plane like this, that is called xz plane. Understand? XZ plane is a plane where x is variable and y is constant. In XZ plane, I have a surface. So if I have a surface, cut the surface at XZ plane. Take any point x comma y on xy plane and draw a vertical that is going to hit a point on the surface. There, draw a xz plane. In xz plane, at that point, try to see xz plane is two-dimensional. where z is variable, x is variable, means x is variable and z is dependent upon it, y is constant. Calculate dz by dx. How much z is changing if I move one unit along x-axis, dz by dx. How much is dz by dx? How much is dz by dx for g1, dg1 by dx? How much z is changing for g2, dg2 by dx? Because g2 is z, dg2 by dx. Okay, means these two surfaces, how much they are changing, how much they are changing in z-axis if I add together. Makes sense? I have a G1 surface, I have a G2 surface. G2 surface is changing if I move along x-axis, keeping y constant. G1 surface is changing along x-axis if I keep y constant and change along x. For one unit, how much is the z is changing for G1 and how much is change Z2 is changing, Z2 or G2 is changing for one unit. At same x, if I calculate for both of them, then together they will change dg1 by dx plus dg2 by dg2 by dx. Okay, I can say that they are changing dg1 by dx, dg2 by dx. Make sense? Okay, this is how they are changing. How much they will change? How much they will change if in y direction? dg1 by dy, dg2 by dy. One is I vector, one is j vector. Makes sense? If I take cross product of these two, then I will understand how much G1 and G2 are changing per area. dg1 by dx cross dg1 by dx cross dg1 by dy will give how much G1 is changing per area change. Makes sense? dg1 by dx says how much height is changing per unit change in x-axis. dg2 by dy say how much height is changing per unit change along y-axis. One is I vector, one is j vector. If I make a cross, the resultant will be k vector, and actual English expression would be how much height is changing per unit change in x and y or per unit change in area. Means if I make cross product of dg1 by dx, dg2 by dx cross product with dg1 by dy, dg2 by dy, then it will give how much g1 and g2 are changing per unit change area change. This is what we want. In multivariable case, we want x to be replaced by xy minus gx to be replaced by g1 g2, and in denominator dgx by dx to be replaced by how much g1 and g2 is changing with x and y area. dgx by dx means how much g is, that is y, how much g is changing per unit change along x-axis. Now we have two components g1 and g2 and both are x and y variable. If I take together, then I would say how much G1 and G2 are changing per unit area change, delta x, delta y, and that will come as cross product of G1, dG1 by dx, dG2 by dx, dG1 by dx, dG2 by dx, dG2 by dy, dG1 by dy, dG2 by dy. If I take cross product, one is in I direction, one is in j direction. Their magnitude will be different, and that's how the actual change will be. Now, if I want to do cross product of these two vectors, I have to take Jacobian, and that is if I take in a vector, first vector is dg1 by dx, dg2 by dx, whatever two we have. Next is dg1 by dy, dg2 by dy. I think so. Yeah. If I take this, then first row will come dg1 by dx, dg1 by dy. Next row will come dg2 by dy, dg1 by dy. Hope dg1 by dg2 by dx, dg2 by dy. This is the Jacobian, and that is a matrix where first column is one vector, that is the change along x-axis. Another column is another vector that is a change along y-axis. I have to take cross product of it. Cross product means a matrix. If I want to take cross product of two vector, I can arrange in a column manner, and that is a matrix. That is cross product. Dot product is not the matrix. Cross product is the matrix because finally I'll calculate the determinant, and that will be the matrix. So it is now dg1 by dx, dg2 by dx in first column, dg1 by dy, dg2 by dy in second column. This is the solution for dgx by dx in multivariable case. Accordingly, when I am seeing it is coming as a shortcut, we can write as dg1 by dx, dg1 by dy as the first row. Then we can just say delta g1, delta g1 by delta x, delta y. Second row will be delta G2 by delta X delta Y. How much G2 is varying with 1 unit area change and how much G1 is varying with 1 unit area change. This is what we are saying that we can successfully bring into a matrix form. The numerator will come in matrix form. Matrix 2 row G1 G2. Outside minus is there and x will come again in matrix x and y. Now place any x and y, and you see that we will do one more session where we will try to practice more on the vector terminology, because vector terminology may look cumbersome and confusing. So we will calculate surface area of a volume through vector, and then we will see little bit related to this, that we will see. Whatever proof I have given, this is also not available in any of the books. Previous proof, tangent through tangent surface, loosely I was seeing yesterday, loosely it is available in somewhere, loosely. And first proof we have given exactly through Jacobian, that is also not available in any of the books. Three solutions we have given. In multivariable Newton case, anyway, please don't mind supporting us. +91 is the in a country code, 948316061 is the telephone number. +91 is the in a country code, 948316061 is the telephone number.